You have to not this one.
Yeah. Hello. Hopefully you can hear me, both people here and online. Hello everyone, once again. My name is Nadira Talaeva, representing here Nagoya University. And today I'll be talking about discovering emerging urban hotspots based on satellite imagery with combination with human mobility data. So, what if you could spot the city's next hidden gem before everyone else does? From overlooked alleyways to rising cultural hubs, cities evolve faster than we notice. And sometimes it's really hard to catch up with this new buildings, new events happening around us. So we figured out there are some gaps in discovering new points of interest. Traditional discovery ways or tools like social media or Google Maps or different trip itineraries, they detect new spots, but often they do it after the place is overcrowded or maybe closed within a missing opportunity. So we decided that our goal would be to develop a system for early identification of urban hotspots. So we will be focusing on detecting emerging places before they become publicly known. We want to rank these locations based on significance and activity and recommend relevant hotspots based on your functions. We've done some literature review on trying to understand if there were previous work done on using both modalities to identify interesting spots in the city. In the city, and we figured out that a lot of people try to focus on one side, like human mobility only data or POI data, and no one has addressed the change in the city using satellite imagery and how people react to these changes. So in our work, we decided to do this by combining satellite imagery like remote sensing and human mobility GPS data, in particularly stay points, stay times. So the framework will be similar to the one that you see. So basically, there are a lot of words, a lot of technicalities, but what you see is that we try to do first remote sensing analysis to identify new buildings, new reconstruction sites, new renovation, new public space for people. We detect it, and then we try to see before and after activity before the event has occurred to identify whether people like this place and start going to this place more or vice versa, they lost interest. And then we do the data fusion to identify and to understand what are the top 3 categories for people and what 3 different types of location they are interested in. So now I'm starting with the remote sensing technology. For this purpose, we decided to use synthetic aperture radar imagery. So for those who are not from remote sensing or satellite imagery background, there are different types of satellite rasters or images we can analyze. And the one that we chose is, first of all, it's really sensitive to buildings and constructions. And also it's really effective in a sense that a lot of satellite imagery gets covered by clouds, but this one is helps us to identify newly emerging spots, even if it's cloudy or some cloud coverage is limiting our view. So the 2 key components of this approach is using saturation and hue. So hue stands for different types of colors, and saturation stands for the intensity of the color. While hue represents the timestamp when the change has happened, saturation shows us how intense the certain change was. So by filtering out the big saturation points, we can identify buildings from seasonal noise, like vegetation change or like people moving and everything. So as a result, when we implement this technology using remote sensing in the city, we get this kind of map with different signs that were built. And looking at the graph over here, we can see when this change happened, and we can see how the city was evolving from 2018 to present. Here you can see different locations. I don't know if I can show. Like the shopping mall over there. Oh, thank you. Like the shopping mall over there that was built in between 2021 and 2022, or different location that has been changed throughout the years. And you probably want to remember this site because you will see it further in the presentation. Oops. So now, after we're done with the satellite change, we are gonna focus on how people react to this change. For this purpose, we decided to use the area-to-vec model, which was originally inspired by word-to-vec, like word embeddings, learn meanings in language, but here words are represented as space. After doing the analysis with area-to-vec model, we retrieve 5 different types of clusters, which represent the regions and their functionality, starting from the commercial sites like shopping malls, residential areas, office places, amenities, and tourism. For this research, we will be focusing mostly on recreation and tourism. That's why we will be working with cluster 1 and cluster 5. So I think you can see that it represents, for example, the residential area by stay times. So it means a lot of the time people stay in houses, and especially prolonged stay hours at night. So this is how we differentiate different types of regions in the city. And then to identify the intensity of the change, we implement cosine similarity to identify the difference between time period 1 and time period 2, to see if people are actually start staying in this location more, going to this location more, or vice versa, they lost interest. So we divide the map into 100-meter grids, and then we calculate the difference. And the higher values mean that greater social attention change. And then that's the most important part regarding how we fuse these two different data modalities. A lot of the times researchers that combine environmental data and human mobility data, they do it in different ways. Like they take, for example, raster imagery and try to fuse it with vector. Inspired by raster calculations and band calculations, we proposed the method that will allow us fuse GPS data and turn them into basically satellite imagery. So here I try to show a little bit of structure of satellite images. The most interesting part is that satellite imagery consists of different bands. And we thought, what if we could take human movement, human activity data, and turn it into one of the satellite imagery bands, so that when we combine different bands of satellite image rasters, we get different analytics of human movement based on environment. And here, after we fuse it, the important point is fuse it with regards to time, because we need to be sure that the change happened because of the building. And the hue aspect of it acts as an anchor for this purpose. And then after we compare GPS activity before and after hue, and then we try to introduce an attraction score. And then we need to do some raster calculations for normalization and then calculate it by different weights. And then we try to evaluate it based on different metrics and parameters. So different modalities need different parameters. And here we, for example, for physical change, we mostly focus on saturation and hue, as mentioned earlier. But for behavioral change, we decided to take the cosine difference as well as unique user growth, as well as weekend and evening z-scores, because leisure and recreational places mostly interesting to people in weekends, especially for the ones who are working. And then we also try to identify median dwell time shift to capture deeper on-site engagement. And then by using this formula, we calculate the score and then break it into several quartiles. And then when we implement this for Nagoya City from 2019 to 2024, we receive 962 emerging hotspots ranked from 1 to 3 by their priority. 3 shown here in red, which means interesting place, and yellow, less interesting. So the metrics are total visit growth, unique user increase, weekend evening spikes, and etc., introduced in previous slide. And then we try to validate whether or not the point that we chose actually a new interesting place in the city. And then if you remember, I told you about the shopping mall, and we see here that in 2019, there was nothing on this location, but then the new shopping mall appeared like in 2021. And then we can see the temporal profile of the construction. And this is the result of our satellite analysis, which shows us that the process is valid, but there are some things we need to keep in mind. Of course, we did a lot of contribution regarding the multimodal fusion, like moving beyond reactive approaches or introducing raster-inspired fusion, as well as opening ways to human-aware environmental monitoring. But there are a lot of things we need to do for the validation and scaling of our project. And the most important thing we need to keep in mind is that there are temporal gaps in satellite imagery, especially in the open source ones. The revisit time is often 5 days, and we need more high resolution, spatial temporal resolution images for better results. The threshold sensitivity should be kept in mind, and it should be adaptive to different cities and different people that we work with and analyze. And of course, sometimes it's difficult to identify why some change happened if we cannot track it with satellite imagery. For example, if there is like a small shop inside a shopping mall that attracts a lot of people, it might be a bit difficult for us to understand. So we want to implement more modalities like POI data or social media for validation. And we hope that it's not just about urban change, but also about early urban intelligence. So thank you very much. Have any questions?
Do you have any question?
Thank you. Very interesting presentation. Who could be the users of this kind of data? What could they, in the best case scenario, get out of it?
Yeah, that's a really good question, and that's the question I've been asked a lot by my supervisors as well. I think as someone who now studies in Japan, who tried to explore the region, I would be also interested in this kind of project. So I think it would be interesting for both tourists and local people who have been living there, but they don't really have time to explore everything, as well as maybe for urban planners to identify the spikes and interesting places and put the right investment into right place.
Any other question? Actually, I have one question. Actually, you have a data from 2019 to 22 or 24. So actually, can you find something to investigate data from this time? Just well, maybe I think you show us one example that when new
Buildings,
shopping mall,
Yeah.
but I think the data is very interesting. So then you can you find a more interesting finding from our data?
Yes, actually, the interesting part is that this is from open source results, and it has really interesting results, even if it's like publicly available data. So apart from new buildings, you can also identify the vegetation change. So, for example, the blooming of sakura, we were talking about this as well. Or, for example, new types of crops that were in the fields and how they changed the type of crops, as well as just like environmental parameters as like vegetation index, air quality, and everything could be encompassed. But it's just the beginning, so we're starting with urban change.
So what is the final goal of this project? What?
The final goal is to be able to fuse human activity and environment to identify how these two factors affect each other. I think it's really important for sustainability as well as research field as well.
Okay, thank you very much.
Thank you.
Any other question? It's okay. Okay. Thank you very much.
Thank you.